Hello, my name is Olena Babenko. I am a software engineer in Ivan, and today I'm going to present a talk called SQL Everywhere. Today I'm going to present a story, and my story is about communication. Well, strictly speaking, computers do not need programming languages and scripting. Humans need them. Humans need programming languages and to describe their intentions and share their ideas and thoughts with others. Well, vast majority of the most commonly used languages created decades ago, but still this problem exists nowadays. So people who write the same language have a problem to understand each other. And especially if they have different background and experience. Well, today I'm going to present small solution to this problem. And because this is a Flink conference, this should be also about data processing and analysis. Well, some time ago, I work as a data engineer and backend engineer in very diverse team. It includes business people, product people, analysts, backend engineers, data engineers, scientists, and not just data scientists, but scientists with PhD, not in IT field. After some time working together, we decided we need some common languages to understand and share each other ideas. However, there was not much languages to choose from. Well, so we chose Python. Well, right? And everyone knows Python nowadays. However, the problem with the Python is that if you hire a good analyst, you not very often ask him about good best practices in writing code in Python. You do not ask about best pattern and unit tests. Also, because they are good analysts, it's not required. And from this, some problems started. For example, scientists forget about some edge case or do not know about some problem in the Python languages, and he introduced an error, and it become an inherited error because data engineer or backend engineer did not know if this is a bug or a feature. Big problems and misunderstanding happening when the static request that analysts and scientists usually work on converted into a streaming application that work 24/7 and should predict possible errors. So today I'm going to present an alternative, not very new one, SQL Everywhere, but I'm going to present how easy it is to collaborate using SQL and Flink and Flink SQL client, especially to find common ground with the people who do not have many common languages and works in side by side using one tool. Well, to show the collaboration of analyst and data engineer, I will present it on using the real business use case. Let's imagine that there are some big changes on the main page, and business people want to calculate how these changes influence the revenue. User behavior, like if the person click or view or buy something is available in the stream in Kafka, and the prices stored in a Postgres database, and results needs to be displayed on dashboards in near real time. Well, to be honest, it's not recommended to stop A/B test earlier or look at the results too early. However, it might be useful for engineers to look at the results because they want to check if there is some big errors on their side. If this happened, for example, you immediately see the huge difference between a revenue in two groups, and also analysts can use some biasing or some new methods to apply to calculate some confidence interval and find it if there is a big difference between two groups. Because if there is a big difference between two groups, you can actually find it early and save money for your company. So that's why we need to dashboard to show the change in the results. Our data set is very simple. There is a topic in Kafka user behavior that has a user ID, item ID, group name, the user, group name A or B, and behavior, Postgres lookup table with the prices, and a Kafka topic where we store actually the result of A/B tests, average revenue, total revenue, and group size. Well, let's start with the analyst point of view. Analysts usually get used to the tools that optimize for the heavy requests that can process the months, even years of historical data, such as BigQuery or Presto. In this example, analysts make a request to the Presto. This is the same request, just with a with statement to it just more readable and help you to understand what's going on. So first we need to enrich user behavior, source with the user behavior with pricing data, and then calculate the results. And from now on, we're going to use exactly this request in our example. So analysts use some toy dataset, make request in Presto, and check that it's working on a historical dataset or toy dataset as in this request. So now it's time for them, for analysts and data engineer, to collaborate together. Well, they're going to use the SQL client for this. Analysts start a SQL client locally and try to run the same request he ran on Presto. However, he knows that he needs to some data source, and he expects, so probably it's not connected automatically to any data source, but he still wants to try things to see what error it returns. So it said that the key table option does not contain an option for key connector for discovering connector. This means that he need to specify where he get this user behavior table from. So he asked a data engineer, so can you please help me to connect to the Kafka in this case? And data engineer say, okay, you need to drop your table first, and I will show you how to connect to Kafka. Schema of your table is totally correct. You can keep it, but you need to add something extra. This is a properties to connect to the proper production cloud, Kafka in the cloud. You just need to change the topic name, the behavior. Also, you need some credentials, and this is the server you need to connect to. I will provide you with these credentials. So, and our Kafka is running in the cloud, even if it's testing Kafka is still in the cloud. And our behavior topic has a toy data set with 4 messages and 2 user and 2 groups. In general, we expect to have at the end the same results we have in a toy data set in Presto. Well, we have this 4 messages. That's great. We have connection is established correctly. We need the second data source. This time, this is Postgre. It will be much easier. And connect to Postgres. It has less properties to connect to. We specify the username, password, and right now it should work. Right? It returns us some results. So it's time to try our request that I showed you a couple of minutes ago. So it looks like it's working. It looks a bit ugly. It's not clear what Expr2 is, but it's working. That's nice. Our first step. Okay, but now our software engineer and analyst collaborate together like in a pair programming on the same tool to actually convert these static queries to a streaming application. First, they define an aggregation window. So they define how often we have enough data to calculate results and send it to our dashboard, to Kafka, and handle some problems with the client, handle late events. First thing we want to get rid of is the hard-coded dates. We don't need it for applications that run 24/7. We are going to replace it with windows, to be specific with window table value functions. Together with engineer, they decided that, first thing we need to test our request, we need to generate some data, because it will not, if the data is static, it will be hard to test that our requests are working as we expected. So let's look at our behavior again. It looks like we constantly generated some data, and now we can properly test our request. Now we are needed to add a table here. Together with data engineer, we decided that it should be tumble window, probably the easiest window to start with, and it's good enough for the first version. However, we see some errors here. It says that it requires the time column is a time attribute. So what does it say? What does the Flink says is that it does not understand how to make this streaming application, how to make this streaming. He needs some time attribute to run streaming application forward. There is event time and processing time, but we want to, for our use case, we actually want a time when the event happening on the client side, not when it happening on the analytics computer. And we have a field called occur at that we can use for these purposes. However, we need to specify it. First, again, we need to drop our table and create our recreate our table again, with this things called watermark, and create a watermark for our timestamp occurred at. Now this become the time attribute, and using this time attribute, our job, we are going to move forward, and we can monitor it and see if our job is moving forward. So we have one more problem. The precision of timestamp is not correct by default. Timestamp precision is 6. Unfortunately, it does not work for our time attribute. We need timestamp with a precision 0, 0 to 3, but it's easy to fix. First, Googling results through Stack Overflow tell you that fix is very easy. Let's try to create our table again. Now it's created. That's a great sign. Let's try our request once again. Okay. We have an error again, but this is a new error. That's great. It says row time attributes must not be in the input rows of a regular join. So it does not like our join function with a price. Why? Well, basically because our Kafka source is not right now working with a time. It's like it's a streaming application. It's a streaming source, but our PostgreSQL does not have any timestamps, and we need to connect them somehow. To solve this problem, we can use the connect the system time and connect this PostgreSQL source as a lookup table using system time. I will show you how to do this. Data engineer probably know how to do this also. And for this, first we need to add, connect them, join the prices for using system time and field called process time in our user behavior. Again, unfortunately, we have to delete and recreate our table one more time with a new field process time. But now Flink will know that you have to use the table. You have to use the time when the actually event appear to connect this with the data from Postgre, from the lookup from our lookup table. And let's run again. One more problem. It says that please use window table window function with aggregate together as a window start or end as a group keys. It's very self-descriptive error, and it's easy also Google it how to fix it, so Analyst can fix it by himself. You need to just specify the group by window start and end. Also, probably Analyst wants to add some this window start and end for monitoring purposes in more human-friendly form to make sure that we are doing everything correctly. Let's run it again. And it's working. It looks ugly. Again, it has the expression number 0, but it's working. It calculates every 10 seconds some results. That's great results. We achieve it very fast. However, it's not exactly what we want. We do not want to show the table in SQL client. We want to output it to Kafka. Kafka topic called A/B test results. But it should be fast after what we've done already. Basically, this is the same Kafka, and we know how to connect it already. So Analyst defined a schema for our results. And the response will be in a JSON format, and it will connect the name. It will connect fields with a name, so it will look much better. The field will be named. We will know what is what. Just we need to change the topic in a Kafka and create a new sink. In this case, this is not a source, but a sink. And last, very easy step, just insert into this table and add this to our request. Now let's see. Hope there will be no errors anymore. Yes, job ID. So it's actually start some job in a Flink cluster. Let's check the results in our Kafka console. Let's check new messages that we have here. Yes, we have some average revenue, total revenue, or everything that we saw in a table right now in a Kafka. Nice. And we achieve it for 2 minutes? Good. So now let's look at the software engineer point of view. He had a bunch of SQLs, but he need to convert it to deployable and testable jobs that in the future where you can add a login, monitoring, and add a job versioning. So, and he probably want to add it in languages like Scala. So he create a project from template and create using Blink Planner in streaming mode, create a streaming table environment. And what he need to do is just copy paste the SQL that he created together with Analyst. We need to add a A/B test result sink here. Also can copy paste, but probably we want to use a bit different topic. Let's call it staging, to not interfere with our previous testing results. We could also change our sources to some production database or staging database. This is expectable. This is expected from data engineers. So we copy paste this SQL, this request. Let's run it. So it's compiled. Yay, for Scala, it's a good sign. Let's see, what do we have any results there in Kafka waiting for us. Yeah, there is a new topic, A/B test result staging. Let's check for a new messages there. If it's actually working, yes, we have new messages and 40 new messages. Let's wait a bit, couple of seconds. Yeah, we have 8 more messages here with a total revenue, average revenue, and stuff like this. So let's recap what had happened. On the first iteration, we have some SQL requests, how to work with the Presto, how to create a table in Presto. We change it to the Postgres database by adding the connector of the Postgres We also, for a Kafka source, we do not change almost anything in schema itself, just adding watermarks to edit actually streaming, to use the to explain to our job that we need to use the event time, not a processing time, and connect to our Kafka. And finally, our request. There was some problem with connecting to the Postgre lookup table without timestamps, but we solved this using system time. And also we introduced the tumble window just as the beginning with interval 1 minute. For production, it makes sense to use 1 minute, not 10 seconds. 10 seconds is a bit too much. What's next? From the software engineer point of view, he need to add tests, add more refactoring, and prepare for the future changes. I believe that this is just the beginning, and we tried with a tumbling window, but we can improve this, and probably other team members want to add some improvements there. So for this case, we do not want to break anything. Let's add some fast test. It's not a unit test, it's integration test. However, it still give us some protection from accident errors that we can introduce when we make some changes. We make a function, public function, with our SQL statement that actually make a request and replace our data source and sync with the files. We read it from the file system. We read it from the files and toy data sets. And we also assert the results, compare the results from the files. And let's imagine that the next day, Analyst came and said, okay, you know what, we need to improve this because we need to take into account only view ID 111. This is a main page. Maybe we want to use some distinct user ID or something. Something else, some new improvement, and engineers say, okay, no problem. I just introduce SQL query. Fortunately, yes, I already did some refactoring using table API, but fortunately, I can mix SQL query and table APIs. Especially, it makes sense when using proof of concept, when you know that there will be some changes there. Again, adding more function, more tests. The problem though appeared when he decided that when engineer decided he wants to use data stream API. In this case, the test should be rewritten. Probably use the Docker containers, test containers, and maybe Faker to generate expected data set. So it's a bit more complex. So maybe it makes sense to do this after proof of concept is done. You do not have to collaborate so often. So what we done here, right? So analysts that used to work with the Presto database easily start working with the SQL client. There was some problems, definitely, but data engineer was there to rescue. And let's face it. It was not that a big problem. You can easily Google the solution for all of these problems. But as a result, they collaborate, they discuss the windowing functions, and as a result, a software engineer have a first proof of concept, running proof of concept already in the first day, very fast. You just copy paste everything and it's just work. How amazing it is! I think this is great. And if you like, I work in Ivan, and if you like how easy it was to look at messages in a Kafka, by the way, this Kafka was in a cloud, so it was not in a local computer. We actually make a request to distributed Kafka and distributed Postgre. If you like how easy to work with the Kafka I show you, here is the link to the Ivan for Apache Kafka. Feel free to try it out. And if you decided to try Kafka, that will be managed for you in Ivan. Also consider to sign up for Ivan for Apache Flink beta program. Well, we use Flink. We use a SQL layer on top of a Flink to help our Kafka user to make simple data processing jobs. So also SQL, like everywhere, right? And that's it. Thank you for your attention. You can ask your questions now.